Ever since my first day of T-ball, baseball has been a huge part of my life. I've played every year since preschool, and when the idea of a student-directed investigation arose, I knew what mine would revolve around. I started brainstorming ideas and quickly realized that there are many elements of baseball that can be changed to either alter performance for the better or for the worse. These changes could be the type of baseball, the leather of a glove, the grip on batting gloves, but the change that I thought would best suit a scientific experiment were the different materials of a baseball bat. After researching online, I found that the most commonly used bat materials were aluminum, composite, BB core, and wood, and luckily I had all of these bats available to me for my use. After continuing my research, I was able to develop a question and a hypothesis. My question was, how does the material of a baseball bat affect the distance a ball travels when hit off of a stationary tee? My hypothesis was that the composite bat would hit the balls the furthest on average. In baseball, there are 4 commonly used materials for bats: composite, aluminum, BB core, and wood. Composite bats are typically made from a combination of aluminum and woven graphite and have an incredible trampoline effect. Aluminum bats are pretty self-explanatory, being made of pure aluminum and are usually made from one piece. BB core bats are similar to composite bats, except they have a large piece of metal in the center of them to reduce the trampoline effect, which makes them safer to play with. Most leagues only allow BB core bats nowadays because they are the safest alternative and provide less injuries for pitchers. Wood bats are just wood bats, but there are a variety of different wood bats like maple, ash, bamboo, and others, but those are the most common. Once it was time for me to perform the investigation, I waited for a nice sunny day and headed out to Centennial Fields. Once I found an isolated field with room to hit baseballs, I set up my 36-inch tee off the ground and placed alongside it my bucket with 50 Rawlings Official League baseballs. Along with the tee and the balls, I had all 4 types of bats and a measuring wheel to measure the distances of the balls. Once my materials were set up, I hit 50 balls with each bat for a total of 50 trials. Between each trial, the distance of the ball was measured. Yes, it did take a long time, but it gave me the most accurate results. The distances were recorded into a data table with 50 trials for each bat, and then averaged out into one total for each type of bat. After collecting all of my data and averaging it out, I finally had the results from my investigation. The farthest a ball was hit by any bat in a single trial was 270 feet by the composite bat. The shortest a ball was hit by any bat in a single trial was 133 feet by the wood bat. The average distance for the composite bat was 255.4 feet. The aluminum was 207.8 feet. For the BB core, it was 178.4 feet, and for the wood, it was 174.6 feet. The composite bat proved to be the producer of the highest data due to its average of 47.8 feet further than the aluminum, 77 feet further than the BB core, and 80.8 feet further than the wood. After a couple hours of performing my investigation by hitting baseballs off of a tee and measuring their distance, I finally had enough data to support my hypothesis. The composite bat did in fact hit the balls the farthest, which proved my hypothesis to be correct. Overall, I thought my investigation went pretty well. Although it took a while, I gathered accurate data, and with that I was able to support my hypothesis and make a conclusion that was backed up by evidence. One challenge I faced was how long it took to measure the distances of all the baseballs, and next time I would try to make this process more efficient, if at all possible. Another challenge I faced, although minor, was that my partner dropped the class partway through the project, so I was pretty much on my own the whole time. Besides these 2 things, the project was successful, and I had fun doing it. I know that baseball will always be a huge part of my life, whether I'm coaching it, playing it, or helping my kids out with their game. After performing this experiment, I now know a lot more about baseball bats than I did before, and this can help me in the real world. The next time I go and buy a bat, I know that the composite bat will be the best choice for me because it provides the best results and hits the ball the furthest. This just goes to show how science can be used in the real world to make decisions and amplify a person's personal game. Thank you for listening, and I hope you enjoyed my presentation about my bat experiment.